For this CFD setup, you're going to be using two applications. One is Onshape and SimScale is the other one. They are both free. So to begin with, you'll be creating the fuselage with the differing noses. So in Onshape, you want to go to Create and just create a new document, and I will be calling this nose fuselage pointy 2.0 because I've already got one. So open. Now firstly it gives you your dimensions here. So what you first want to do is you want to go sketch a plane, click front to do it relatively, and just click that and it comes up here. Now you want to edit it. That is not how you do it, sorry. You go over here, click plane, go front plane, you want to offset it by 5 centimeters. Now you've got this ready. Next, what you want to do is you want to click front, go right click, go new sketch. You want to go center point circle. You want to hover above the circle and drag it out, and you want a radius of 4 for this design. Then click on it, just go edit sketch, and if you click on it again, go dimensions up here, click, and you can edit it here, and I'm going to put 4. Then to join the other plane, what you're going to do is you're going to click on plane 1, go to sketch, and you are going to click do center point circle again, do it here so it hovers above the circle and highlights the center, and you're just going to draw a rough here, and this one you want your dimension to be, so you're going to go click right click, edit sketch, and you're going to go dimensions here, click it again, and you're going to make it, what did I do there? No, go back. Going to make it as small as possible, so I'm just doing 0.01. Now what you want to do is you want to hover this and click that. You want to go up here and click loft. What it's going to do is this is going to act as your nose of the aircraft. So what it has done now, this is your pointy one, and using this logic you can go ahead and create a fuselage in the design of such as I have here. So this is my triangle fuselage once it loads, and it has deformed by the looks of it, which is not useful, but I can do a different example. This is my flat fuselage. So I can see here, this is the fuselage. All of these are constant throughout the designs. That one's deformed a bit as well. Must have been some editing by accident. Just for fuselage base, this will work. So this stays constant, so you use the same properties throughout all of them, and then the front one you want this to remain at 5 centimeters, the distance of the whole nose, and then this right here, for example, remains at 20 centimeters, and the tail is another additional 12 centimeters, so 32 centimeters offset from that front dimension. After this, you should have a complete fuselage which you can import to SimScale. So now if I do a new SimScale project, it is also free to sign up. So you go new project up here, do a description, so I'm just going to do nose, rounded, because that one's working. Go 2.0, because I've already got named, and you still do small descriptions, so retrial for method demonstration, aerospace, and create project. Just going to open this. So now what you want to do is go Onshape, and you link your Onshape account if you have not already. And I'll just connect what I had then, the fuselage base, which is this one. Go click that and go import. Just take a sec. And it will say CAD models imported, so I can close this. Don't need that anymore. And give it a minute or two and it will show up here. Here we go. So I'm going to click this and you can see it's now been imported. What I do want it to do though is I want it to be rotated, so the front, this fuselage here, it's going that way. So I can get airflow going from left to right. So what I'm going to do is just click up here, transform, rotate, click it, X, and just do 270. Apply that. That is not right, is it? So now I just need to move it along the Z-axis 90 degrees, it looks like. Unless if I do that, will that work? Nope. X, Y. One of these was 270, I believe. No. Okay. So I'm just gonna have to do X like that. And I'll just move it along the Z-axis 90 degrees. Alright, this is not working, is it? That's my mistake. There we go. So it is now heading in that direction. That's exactly how I want it. Now I'm going to add an external flow volume. So this is going to act as the wind tunnel. So if I just get my old project I used, I can find what dimensions I did use. Go round. So what I'm doing here is I'm giving it enough rain for the external flow volume. Oh, so it does appear I did do it differently last time actually. So I'm just going to quickly fix this. So I had the X and Y and the Z axis as primary, so I had it like this. So now if I get rid of this second rotate, which will make a lot of sense, X, Y, and go Z as that. Oh, it's all not going well, is it? Far out. Oh, just leave it like that. There we go. Okay. Go flow volume, external. So what I've done here is I've given about the fuselage length around 5 lengths in between and around, maybe 3 up, 3 this way, 3 that way, and 10 behind. So that gives enough room for the wake and the overall airflow to interact with the surfaces without boundary wall conditions having posing any limitations or interference. So what I'm going to do is exclude volumes. Oh, I don't even need to do all that, so I'm just going to apply that. So now what I'm going to do is I'm going to basically take the space of the aircraft away from this wind tunnel. So it acts as a subtraction almost. If I go Boolean subtract target bodies, it will be the flow region, and the volumes is going to be part 1. Just going to discard it, so I'm going to get rid of it. Going to apply, give that a sec, there we go. So now that is my geometry set. It's basically just going to be one big square, and you can see just there as I highlight it, there is the outlines of the fuselage. So go create simulation, going to incompressible, that's the free one. Geometry set, materials you just want air, apply. Boundary conditions, your velocity inlet, which is your air going in. Going to click the front face, which is in the direction of the nose. Going to put that in at around 240, which is your typical speed of an airliner. And that should match 240 fixed value, blah blah blah. Accept. And now your pressure outwards, which is gonna basically be taking all the air out, because otherwise the air will just be pushed in and kind of compress inside. So gonna do that, leave it all like that. And now you need your walls, so boundary walls, so the air doesn't escape obviously. So then go 1, 2, 3, 4. I'm gonna do it as wall function slip, so it doesn't exact stick or impact it, and just go accept. Now result control, I'm gonna add forces and moments, and just keep it all like that. And what you can do is just assign it to click flow region, and then you can just click on the boxes to exclude them, so you only have your part 1 inside, because remember they have been merged, so you can't specifically click that. And you can see kind of this sphere highlighted here. And what that's going to do is just give you all the data you need from this experiment. Go accept. Now you're meshing, so you want a really fine mesh. So what you're going to do is click that. You're going to go as fine as possible. Then for under boundary layers, you're going to go what I did in my past one. 10. So you do number of layers 10, that keeps it very thick. Overall relative thickness, really, really thin. Growth rate, it was 1.2. And that is set for that. Now your refinements. So surface custom sizing, what you can do is just make it really fine as well. And I believe that is just, it might be the whole thing. No. Just do the same as before, click flow region and then just get rid of the boxes. So that is set. And now you need your volume custom sizing. So that's going to basically be behind the aircraft, and what it's going to do is act as like basically an area in which you analyze the weight, because otherwise it won't generate as much. So in doing this, you can almost like basically keep the weight as in detail as the aircraft and how it behaves. So distance, so you want to change this to distance, meters, and you're just going to do these values going to go 0, what was it, 1 and 2 0.5 and 2, 0.5 and 2, and just going to go 0 and 2, 0.4, 0.4. And assign that is just for flow region. And what you may be able to see now, if this starts acting up, refinement areas, now you can do a Cartesian box, which is where this is going to be, behind the fin obviously. So these are the boundaries I made for mine. It may be different depending depending on what type of model you do or how big you want it. But this seems to be exactly where I want it and exactly how big I want it. So now if I get rid of that, oh, how do you see it again? There is a way to see it and I forgot. Oh, here we go. Wasn't highlighted. So if I get rid of that, you can see around there's the end of the tail, and when I click that off, that's about where the weight begins with the air coming in this direction, that way. Which is pretty useless when I don't have the fin on. You can see it though, that's the outlet, and this is that's the outlet, sorry, and this is the inlet. Now simulation runs. Oh, cancel that first. So what you're going to do now is you're going to generate the mesh. Just takes that's way too long. It takes about like 10ish minutes. So mesh is just finishing up now. You can see 95%. It's taken only 2 minutes, which is way off the hour-ish it said it would take. So give it a sec. So first you want to just inspect it and make sure it looks relatively what it should like. So it's just going to come up like this. You can zoom up, and in terms of what we're after, a basic shape, that's pretty much perfect. You see it's not too coarse and it is fairly streamlined, and when you put it into the simulation, you can alter it to become even more smoother with the airflow. So now what you're going to do, go simulation runs, just go run anyway, ignore that, go run 1, go start. You're going to wait around, it does take around 10-15 minutes, some take up to 40 minutes, but you can log out. It's all on the cloud CPU and it will send you an email once it is finished. So I'm just going to go to post-process results here. That one did take around half an hour, which is typical. So now you can see it down here, you're in solution fields. So at the moment you can kind of faintly see here the aircraft fuselage. So what I'm going to do is just click on these and then right click and just go hide selection. There we go. Just get rid of all of them. Okay, part colors. I want this to be pressure, because that is what I am after. Opacity, make it full so it's easy to see. Now for the cutting plane, keep it Y. What I want is if I put it back to the front and zoom in, I want it to be about halfway up the fuselage. So if I move it down, it's just going to be a little minor finnies. So if I go 1.2, oh that's moving up, so maybe I want 1.3, a bit lower, 1.4, there we go, that'll do. So you see it's right in the middle of the nose fuselage. Alright, orientation, velocity, vectors I do want on. So I want this at 0.6, 0.02, I want the clamping to be around low to mid, and then I want filtering as high as possible. And opacity, I want it around 0.7. So now I can see here the pressure and how it reacts. So the wind is coming from, here we go. Wind's coming from this direction, going that way. So I can see that there's a slight pressure build up here, as seen by the red. What I'm going to do is just change the pressure to about 3.08. Keep this at 1. speed to be around 240 as the fin. So now it's all red. See, as it flows over here, it slows down slightly, as seen by the yellow, but the weight is not very big. Otherwise you would have a massive weight going out. And it does kind of bounce off here, and you can see this is the stagnation point where it all slows down, right on the tip. Then that's terms of pressure. Now if I want to do a visualization as in terms of particles, what I do, all I do is I just unhide, get this box out again, change the opacity slightly down, just so I can see this. Click on bottom so it's right at the front. Just go up here to particle trace and I just click on around this side. Now what I do, you see you've got the particle trace going now. So I like to use spheres. So I want this flow region back on, by the way, and just going to do what I did before and hide these. So click them, hide selection, click the other three, hide selection. So now I've got a side-by-side view, so what I'm going to do is do number of pulses, going to turn that right up, going to take some horizontal ones off. Size, I want it right down, and spacing, I also want that right down. No, I might do size a bit higher, so if I change it to maybe 3, yeah, that'll do. So what this is now is basically this coming in from that way to more pulses. That's for airflow, and it's basically how it's been disturbed as it comes through and the streamline of after. So if I can go back here, and I can see the wake and the overall drag turbulence. For a rounded nose, it will obviously differ from a pointed nose, as seen here. The pointed nose has a lot more of a streamlined wake and organized. And what I can do as well, so go front, zoom back down on it. I want to get rid of that, sorry, remember to not trace both directions. Is I can do an animation, so then if I go up here, animation, just to make it quick, I'll go animation speed high, skip frames, and I want it to be particle trace. Steps, do like that. And just give it a sec as it comes through, because it's coming through from the edge of the square, remember? So as it moves down, you see it now, you can see the animation of how it's streamlined. You can see it kind of does stick to the fuselage for a while, so the flow is very streamlined. The disturbance isn't very high. You can see that it's not very mitigated on how it does. It's not as good as a pointy nose, but then these results are comparable. And if you go to your moment log and you do the forces, which we did, it gives you an ideal forces and just some data you can refer to alongside this visual representation. So basically this summarizes on my method on setting up the CFD. Thank you.